Alright, section 4.4, we are now solving trigonometric equations. In this case, we want to find all real numbers in the interval from 0 to 2 pi. Now this question, we have cosine squared, we have cosine, we have 1. So if we had this problem, x squared plus 2x plus 1 equals 0, this would feel a little bit more like Math 990 or Math 1010. That's really all we have. So the factoring x, 1, 1 plus plus, that's the same factoring that happens here, but it's cosine x plus 1 and cosine x plus 1. This equation will give us cosine x plus 1 equals 0, or cosine x equals -1. And this one equation will give us the same answer. So we have to figure out where is cosine -1. Now think of the graph. Cosine starts at 1, then to 0, then to -1. So our final answer, this is the only spot around one time around the circle where cosine equals -1. That would be at pi. That's our answer, pi. Often, a question like this second part will give us more solutions somewhere, and then we'll have a longer list than just one. But in this case, this ended up being a perfect square trinomial, which gave us just one solution. Alright, moving on. Once again, solutions from 0 to 2 pi. In this case, we don't have it equal 0, so I'm going to subtract sine x from both sides. We now have equal 0. On the left side, we have 2 sine squared x minus sine x. We cannot add or subtract those because they're not like terms. It's like x squared, 2x squared minus x. It's always nice to think about what this is equivalent to. So you can think, how would you factor? In this case, the factoring would be a greatest common factor. So we can factor out a sine x, leaving us a 2 sine x minus 1. Make sure that when you factor out from sine x that you understand factoring divided by sine x is dividing by sine x. And sine x over sine x is 1. Alright, this equation gives us sine x equals 0. And this equation gives us 2 sine x minus 1 equals 0. Or 2 sine x equals 1. Or sine x equals 1 half. Right. First off, where is sine 0? Well, sine is 0 here and here. So that's 0 and pi. Where is sine 1 half? Sine is positive in quadrant 1 and quadrant 2. Sine is 1 half at 30 degrees, or pi sixths. And 5 pi sixths. These are our solutions. X equals 0, pi sixths, 5 pi sixths, pi. Alright. Make sure that you know whether you need all solutions or just a few. And if you have just like from 0 to 2 pi, then know that, like right here, had this said sine 2x, then we need to go twice around the circles. Twice around the circle, getting all the spots where it equals 1 half. In this case, it's just 1x, so we went just the one time around the circle. And also, because all students take calculus, we know that sine is positive in quadrant 1 and quadrant 2. That's why we just stuck to quadrant 1 and quadrant 2. Right, next question. So in this problem, we have cosine x equals sine x. Again, looking between 0 and 2 pi. Cosine x equals sine x. One thing we can look at is directly, where does cosine x equal sine x? I know at 45 degrees at pi fourths, because they're both square root of 2 over 2. But not second quadrant, because sine's positive but cosine's negative. Also third quadrant, and that would be 5 pi fourths. Sine x equals negative square root of 2 over 2, and so does cosine. So those two values are our final answer. And this is looking for where is cosine x equals sine x, and that's at 45 degree angles where they're either both positive or they're both negative. Okay, this is one way that you can do this problem. There's another way, and this is an approach that people often use, and that is to recognize when you have two trig functions, it makes it hard to work with. But if you only have one, then you can do other things. So if I were to divide by, for example, cosine, I have to make sure that cosine is not equal to 0. So at the end, I don't want to divide by 0. At the end, I'll have to check into that. But I get 1 equal tangent x. This is awesome because it's one trig function. It's just tangent. Now it's not sine and cosine. Where is tangent equal to 1? Well, all students take calculus. Tangent is equal to 1 at pi fourths and also positive 1 at 5 pi fourths. It gives us our same solutions. And in neither pi fourths or 5 pi fourths does cosine x equal 0. So I'm not going to have a divide by 0 issue. Anytime you divide by a function, you always have to worry about making sure that's not 0. And again, at our two solutions, cosine is not 0 there, so that's a safe step. So these two solutions are it. Okay, next question. Sine squared x minus cosine squared x equals 0. Now I know that an identity that has cosine squared x minus sine squared x, that equals cosine 2x. Not exactly what we have, however, I can factor out a negative 1 and make cosine squared x minus sine squared x on the left. That's negative cosine 2x. We can then multiply by negative 1, getting rid of those, and have cosine 2x equals, and that's just 0. Alright, now we're looking for solutions from 0 to 2 pi, and we have a double angle, so we know we need to go twice around the circle to get all the spots. So first off, where is cosine 0? Cosine is 0 here, that's pi halves, and here 3 pi halves, but that's only one time around the circle. This is how you count by pi halves. 1, 2, let's try that again, 0. 1 pi half, 2 pi halves, 3 pi halves, 4, 5 pi halves, 6, 7 pi halves. So again, pi halves, 1, 2 pi halves, 3 pi halves, 4, 5 pi halves, 6, 7 pi halves. So we get 4 answers. 2 that are equal to 90 degrees or coterminal with, and 2 that are equal or coterminal with 270 degrees. So we have 2x equals pi halves, 3 pi halves, 5 pi halves, 7 pi halves. That's about the weirdest looking 5 I think I've ever written. That is a 5. Now we divide by 2. 1/2 makes it easier because we're already in fractions. This gives us x equals pi fourths, 3 pi fourths, 5 pi fourths, and 7 pi fourths. And you will recognize that all 4 of these answers are one time around the circle. When you have multiple trig functions, like in this case sine and cosine, like our previous problem, a very common thing to do is to try to use identities to get them into one trig function. In this case, our double angle worked out nicely, which changed us to looking for 2 solutions. Okay, moving on. Before I move on, I said 2 solutions. I mean 2 times around the circle looking for solutions. Now let's move on. Okay, so let's take a look at this. Sine squared x equals 8 sine x minus 4. And the instructions 0 to 360 degrees and round approximate answers to the nearest tenth. This must be approximate answers because we must have ugly solutions. So if we have ugly solutions, let's take the ugly out of this for a minute. Let's let u equal sine x. I recognize the quadratic nature, squared, not squared, constant, three terms. This is a quadratic wannabe. This is quadratic form. If I let u equal sine x, then I have u squared minus 8u minus 4 equals 0. This doesn't factor. However, I can do the quadratic formula. Opposite b plus or minus the square root of b squared minus 4ac all over 2a and get our answers. This would be 8 plus or minus square root of 80. On my calculator I did negative 8 squared minus 4 times 1 times negative 4 gives 80. All over 2a, which is 2. You can simplify. 80 is 4 times 20. So it is 16 times 5. So we can square root 16 and get 4, and then square root 5. I'll divide by 2. And now we can reduce by 2. Basically dividing by 2 everywhere, giving us 4 plus or minus 2 square root 5. That's u, but wait, that's sine x. That's not our final answer. We have to find x, but that at least gets us to where we can go. Approximate to the nearest tenth of a solution. So we need to now, take you back up here now. That's a weird looking arrow. There we go. We need to work out x equals arc sine of 4 plus 2 square root 5, but also arc sine of 4 minus 2 square root 5. There are two different solutions, so we have to work them both out on our calculator. So let's take a look. 4 plus 2 square root 5 is approximately 8.4721, and I'm going more decimals than I need to because I still have work to do, I think. I'm not sure yet. And now that can't be right. What could be wrong with that? I know what's wrong with that. Let me erase that. And this is something that you'll find yourself doing as well. Degree mode. My calculator is in radian mode, so I got to change back to degree mode. And arc sine okay, this error. We'll investigate that. Let's do the other one. So arc sine of 4 minus 2 square root 5. Negative 28.1730 degrees. That's a 0. Okay, well, why did we get error? 4 plus 2 square root of 5 is bigger than 1. Sine doesn't go bigger than 1. Sine goes between negative 1 and positive 1 when you look at its graph. So arc sine will never accept anything outside of negative 1 to positive 1. Now 4 minus 2 square root of 5 is less than 1. It looks like it's negative because arc sine gave us a negative number. So one of these solutions doesn't work, but the other one does. So our final answer is about right there. However, that's not where we need to be. We need to be between 0 and 360. Alright, so where is sine negative? Sine is negative in quadrant 3 and quadrant 4, but around this way, not backwards, which is what our calculator gave us. So with negative 28.1730 reference angle, this one is going to be 180 plus 28.173 degrees. And this one is going to be 360 minus 28 point da, 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 da. Need a little more room. That didn't do it. Try that again. Move. There we go. 28.173 degrees. So 180 plus 28.173 degrees, that would be 208.173 degrees, and 360 minus 28.173 degrees is 331.827 degrees. Now we can go to our nearest hundredth and have our final answers of 208.2 and 331.8. So this problem had some twists and turns to it. Let's go back and take a look what happened. So first off, we had a quadratic form problem. So we went u equals sine x, so we could get this to a nice quadratic equation. U squared minus 8u minus 4 equals 0. Quadratic formula was needed, and it ended up with 4 plus or minus 2 square root of 5. That's u. But u equals sine, so I went straight to that's equal to sine. So then I went to my calculator to try to find arc sine of 4 plus 2 square root of 5, and that's an error because this number is larger than 1. So that didn't give us any answers. So I went to the minus one, arc sine of 4 minus 2 square root of 5. And that gave me a number that's negative. In degree mode, that's this answer. But we were trying to solve for where sine equals this. Sine, and this is a negative number, sine is negative here and here. We're after just one time around the circle. So we had the reference angle, and we needed to get to these spots. So if we go 180 plus the reference angle, we get one of our answers. And if we go 360 minus the reference angle, we get our second answer. And that's how we arrived at those two. So this one's probably worth a little bit slower attention if you're going back over this one. Make sure you understand the steps that I took. Let's move on to the next question. So this has the same instructions between 0 and 360 degrees and round to one decimal place. So there's another calculator problem. This also is a problem because it's cotangent. But first, let's solve for the trig function. 7 cotangent squared equals 5. Divided by 7 cotangent squared, I forgot the x's. There we go. Cotangent squared x equals 5/7. I don't like cotangent squared. I'm going to go to tangent squared instead, and that'll be 7/5. Then square root, because we haven't solved for tangent yet. Tangent x equals plus or minus square root 7/5. Okay, where's tangent plus or minus? All four spots. Because we have the plus or minus that we got from taking the square root, because we had the squared in our original function, we're going to be able to have solutions in all four quadrants. So let's work with arctangent now. Let's work out x equals arctangent of, let's do square root of 7/5. You do not have to rationalize this because we're going to our calculator now. So arctangent, we need to be in degree mode. Make sure you are. Square root 7/5. 49.797. Let's go to 49.8, since I don't have any other calculations to do other than adding and subtracting 180 or 360. 49.8 degrees. Now if you did the negative one, that would give you negative 49.8 degrees. That wouldn't be any more useful. What we really get out of either one of these is the reference angle. Is 49.8 degrees. So now we just need to go after 49.8 degrees. This first one, 49.8 degrees. we need to get this one and this one and this one as well. This one is 180 minus 49.8 degrees. This would be 180 plus 49.8 degrees. This would be 360 minus 49.8 degrees. We get all of them. And so we finally end up with our four answers. 1, 49.8 degrees. Then we have 180 minus 49.8 degrees. And that's 130.2 degrees. And then we have 180 plus 49.8 degrees, and that's 229.8 degrees. And finally we have 360 minus 49.8 degrees, and that is 310.2 degrees. This completes this problem. So let's take a look at where this problem went. So it started off easy enough. We had just a trig function in there, so we solved for the trig function. When I got to cotangent squared, and I want to reciprocate that to tangent squared, that just flips. And then square root plus minus. The plus minus got that we were going to have all four quadrants. So then when we just went to arc tangent of one of them, gave us a reference angle, and then we worked out the four quadrants of reference angles. Again, if this is 49.8, this is 180 minus 49.8, 180 plus 49.8, and 360 minus 49.8. And we arrived at our four final answers. Next question. All right, story problem. A weight is suspended and we're given a function. P is the position in meters above or below. T is seconds. Find the time when the weight is at equilibrium. Equilibrium is 0. So essentially all we need to do is find when that equals 0. Or in other words, put 0 in for P. Do not find a calculator, but find the exact values. Alright. So we have 1/10 times sine 2t plus sine t equals 0. So let's get rid of the 1/10. We have sine 2t plus sine t equals 0. Now we have sines, but sine 2t and sine t are not like terms. So there really are basically different trig functions. Anytime you have two different trig functions, you need to somehow try to get them into one type of trig function, or maybe something that factors. We cannot factor anything out of this. But here's my biggest hint. When you are working with an equation, you see sine 2t or cosine 2t, think identities. Sine 2t is 2 sine t cosine t. Will this always work? No, nothing always works. But it gives you a different view. These are equivalent expressions because I've used just an identity. For the first expression, nothing factors out of this. This isn't sine squared t. This is sine of 2t, different. But in the second one, notice the sine t. We can factor. So we factor out the sine t, giving us 2 cosine t plus 1 equals 0. This gives us sine t equals 0. This will give us cosine t equals -1/2. That comes by first subtract 1 and then divide by 2, and we'll have -1/2. Alright, we are looking for, find the exact values of when this is at equilibrium. Now this will be at equilibrium over and over and over and over and over, so I do believe we're going to have perhaps an infinite number of solutions. It doesn't specify when, but let's talk about if we have a weight on this spring and it oscillates. Let's look at the future times talk about some of the ways we can express these. First off, when is sine 0? Sine is 0 here, 0 degrees, and here, pi degrees, and over and over and over. And when is cosine negative 1/2? Cosine's negative in the second quadrant, and that would be 1/2 is a 60 degrees, so that would be 120 degrees. And in the third quadrant, that would be 180 and 60, 240 degrees. Or radians, we could also go with radians. So these four answers in radian mode would be x, not x, how about t? T equals 0, pi, let's see, 2 pi thirds, pi, and 4 pi thirds. That's just one time around the circle. That matches up with the key other than having seconds, so it's just 0 seconds. 2 pi thirds seconds. The story problem would give it a story answer, pi seconds. And one more, get a little more space, 4 pi thirds seconds. That's the answer in the key. This continues on forever. So we could also be a little bit smarter about this and recognize we could go 0 plus pi plus pi plus pi plus pi and get all the red ones over and over and over and over. That would be k pi seconds. With the blue one, the 120 or 2 pi thirds, we'd have to add a full circle to get back to that again, to get back to another one that works consistently. So that would be 2 pi thirds plus 2k pi seconds, and similarly 4 pi thirds plus 2k pi seconds. That would express all of the solutions, not just the ones one time around. Why they went just one time around, I'm not sure. It doesn't specify. But either way, we have this solution. So the key to this problem was really at the very beginning. They tell us in the story problem, p equals 0 is equilibrium, and then they said find when it's at equilibrium. So we set p equal 0. Then, two different types of trig functions, they don't factor, so we use our identity, and then we can factor out. And then once we factor, we get a couple different solutions out. This completes the review of the Chapter 3 and 4 material for the second midterm. I hope this was helpful.